about today is something called the law of sines and law of cosines. This comes up in calculus in a couple applications, and it also comes up in life in things like surveying. Like I have a friend who is a surveyor, and he's like, we use this all the time to figure out stuff. And I'm like, oh wow, I should relearn that thing. So here we go. Here's the basic problem. Suppose you have a triangle, either an acute or obtuse triangle, so not a right triangle, so you can't use right triangle trigonometry on it. And so we're going to draw some triangles. So here's a triangle with acute angles. Let's just label them the same so you'll have the same picture. So I'm going to call this side A, this side B, this side C. And I'm just going to use the Greek letters that the book uses for stuff. The angle opposite of side A, they call that alpha. The angle opposite side B, they call that beta. And the angle opposite side C, they call that gamma, which looks like this.
In high school, we just use capital letters.
Yeah, you can also use capital letters for like the sides and lowercase letters for the angles, or did you use capitals for the angles? It doesn't matter, right? But this is the system your book uses. And if it's an obtuse triangle, that means you have one angle that's bigger than 90. So they called this A, B, C, and same naming system. This one's alpha, that one's beta, and they called this one gamma. Okay, so the question is if we know 3 of these 6 values, so like a side and 2 angles, or 2 sides and an angle, or maybe all the angles or all the sides, how are you going to find all of the other things in that triangle? Does that make sense as a question? Okay, so just a couple things to note. First of all, the largest side is always opposite the largest angle. Does that make sense? Okay. So the first question is, if we know all 3 angles, can you find the sides? Yes. The answer is no, and here's why. There isn't only one triangle. So what if I did an equilateral triangle with 60, 60, and 60 on each side, and all of them are 1, right? And what if I draw a blown up version of that, where it's still 60, 60, 60, and all of the sides are 2? Does that make sense? So there are an infinite number of triangles that have like the same angles and different sides. So if you're just given angles, there's a lot of triangles that fit, and they might have some kind of classification to them, but we're not really going to touch that case. So it's because you can scale up or scale down, and the angles don't change, but the side lengths do. So in that case, no. Okay, so assuming we just have maybe a side and an angle or some other combination of that, here's how we're going to go. Look at that first picture. I'm just going to draw it a little bit bigger. So this was my A, this was my alpha, this is my beta. And the law of sines is given below. And what I want to do to you is just kind of show you why it's true, because the reason that it's true is actually just basic triangle trigonometry. So how you prove it, so you just start by taking this angle gamma, and you drop a perpendicular bisector. In other words, this would be the height of your triangle. So this is now a right angle. Does it make sense that you can do that? Okay, and once you do that, once you've made right triangles, you can do right triangle trigonometry. So, for example, what would sine of alpha be? So alpha is this angle. Sine is the opposite over hypotenuse. What's the opposite side to that alpha angle? H over C. Did I mess my triangle up? I did, guys, I'm sorry. What did this should have been C, and this should have been B. So H over B, sorry. And how about sine of beta? What's that one gonna be?
H over B is why?
Because I have this right triangle right here. It's the definition of what sine is this,
Oh, that's right, okay.
right? Opposite over hypotenuse.
Oh, okay, and then the opposite is the B, got it.
And the opposite is the B. I just had those names transposed, so only 2 minutes in to make a mistake. So how about for this angle beta? What's sine of that beta gonna be? What's the opposite side there?
H.
H over A. And then I know that H equals B times sine of alpha. And I know that H equals A times sine of beta. Does that make sense how I got both those? I just multiplied the A and the B over the other side. Okay? And so if these things are both equal to H, they have to equal each other, right? So then B sine of alpha will equal A sine of beta. And then what happens if you divide by B? You get sine alpha equals A sine beta over B. And how do you get the A on the other side? What do you divide by? A. And that gives you sine of alpha over A equals sine of beta over B.
The big B is beta.
The big B is beta, yep, and beta is the angle. Usually has a tail on it.
And then the upside on curly Q is,
The upside on curly Q, this thing,
That's alpha.
where are you?
this one, or this one?
The one, I can't see where you're pointing, sorry. Oh, sorry.
Fish, is that what you're calling curly Q?
Yeah.
That's read as gamma.
Okay.
Fish is alpha. But the point is that these rules come from right triangle trigonometry. So the relationship is if you take sine of an angle divided by the opposite side, it's equal to sine of another angle divided by its other opposite side. So that's the basic rule, and you can prove the other ones. You can prove the other one by bisecting a different angle and doing the exact same thing. So this is what the law of sine says. Sine of alpha over A equals sine of beta over B equals sine of gamma over C. So given the relationship that is in that triangle that we drew, okay? Given that like A is opposite the angle alpha and B is opposite the angle beta. So we're gonna use that to some problems. So here's the first one. You have a ski resort, because for these problems, actually the word problems are easiest. The other ones involve a lot more trickery. So they want to make a lift. So they have a lift from A to C, and they decided it's too steep. So they want to make a lift from this point B to that point C. And they know that it's going to be 1,100 feet from A to B. And what they want to find out is what is the measure of this angle. Okay. So can you figure out this angle in this triangle? Yes, that will be 180 minus 34. So what is that?
146.
146. Okay, spectacular. So we know if we take sine of 146 over 1900, that's going to equal sine of, let's call this one, it doesn't really matter what letter we give it. What do you want to call that angle?
B.
Sure. sine of B over what number? Is that right?
Wouldn't it be better to do sine
No,
of
that's
C?
not right. Hold on a second. Okay, so I have this angle, it's opposite side. Which angle is opposite that side?
C.
C. Okay. Once we found C, could we find B?
Yes.
Because the three angles in the triangle have to add up to 180, so once you know the upper one, so we're finding this angle. Okay, so sine of C will equal 1,100 times sine of 146 over 1900. Now make sure that your calculators are in degrees and get a decimal for this. Give it a try, because I got something for that and I just want to know if you get the same thing. So do sine 146, divide it by 1900, and then multiply it by 1,100.
I got 0.3237.
I got 0.3237. Did you guys get that as well?
Oh, okay.
Did you get it?
No, I already did this.
You did the inverse on already, yep. So now to get at angle C, you'll do sine inverse of that number. And one thing that Alex tells you to do is tells you to use 4 decimal places when you're rounding in the middle, and then you round just to like to 1 decimal place at the end. Which will make your answer more accurate. So what'd you get when you did sine inverse?
71.11.
Really?
That's pretty good.
I got 18.9.
Oh, for angle, okay, I'm sorry.
It's how you're still one step ahead. Yes, yes, yes. So angle C is 18.9. Yes, I'm so sorry. And so angle B is 180 minus 18.9 minus 146. I think 70 is still too big.
What I did was.
Tell me what this is first, then we'll discuss what you did, okay?
15.1.
15.1, okay, great. What did you do?
No, I accidentally applied the,
Another inverse function or something?
no.
Okay.
I did like 90 minus 18.9.
Oh, I see what you're saying. Yep. So once you know one angle, use the fact that all the rest, the total, add to 180 to find the other one. Yep, okay. All right. And you're gonna use the fact that the angles sum to 180 to rule out some possibilities. So one sort of funky thing here is that sine inverse only gives you like one value where that occurs, but technically speaking, so 0.327, the sine is that at 18.9 degrees, and also over there at that value. Does that make sense? And that value would be whatever 180 minus 18.9 degrees is, but you know that's not a possibility here because this angle that you'd find would be too big when you account for the 146. Because then you'd have the sum of the angles in the triangle being over 180. So there will in some instances be 2 possibilities that will both work, and sometimes they won't both work. So we'll have examples of each of those. So here's the first case. It's kind of like when we just did where you've got one triangle. So when the directions say solve the triangle, that means find all angles and all sides. So the nice thing about the previous questions, we only had to find that one angle, which implied finding the other angle, but this one says find all angles and all sides. So I'm gonna call this alpha. Opposite side is A. They told us that's 47. This alpha is 123 degrees. if I call this one beta, here's my opposite side B, and that's equal to 23. There's my gamma side, here's my C, and I don't know that one.
So wait, so how do you know where to plug in everything? You just, does it even matter?
It doesn't actually matter as long as you put the side opposite its angle. Does that make sense? So the picture can be drawn lots of different ways, and the questions that were given in Alex, that does give you a triangle to work off of. But the only I could have drawn that triangle in a different way if I wanted to, it's just that the important thing is that 47 has to be across from the angle of 123. Does that make sense? Okay. All right, so here's how I would reason through this. Since you have an A and an alpha, and you know a B, it's probably easiest to find the angle beta first. Does that make sense? So we're going to have sine of 123 over what number? What's the side opposite? 47 equals sine of beta over 23. So sine of beta will be 23 times sine of 123 degrees over 47. So tell me what you get for that, just to make sure you can calculator it. If you need to use your phones, I don't really care, just make sure that they're in degrees.
0.4104.
I got 0.4104, is that what you got? 4104. And then to find beta, beta will be sine inverse of 0.4104. And what do you get for that? I got 24.2. Okay. Now at this stage, you should just do a quick check. So you have the one angle beta where you're 24.2 degrees, and that will give a sine of this number. What other angle makes that happen? Your book calls this beta prime. Because the sine is the same in that place and that place. The y coordinates are the same, right? So this point right here, which they're calling beta prime, that's 180 minus 24.2. So what is that?
155.8.
155.8. And then the question you ask yourself is, could these possibly make a triangle? So could this angle with that angle possibly make a triangle?
No.
No. This one is too big. So you can toss it out because you're in the physical situation of triangle world. Do you understand why that's too big? Yes? Okay. So this is your only possibility. So then you know one of them. Beta is 24.2 degrees. Once you know that, what's the next easiest thing to find? You know, C's not so hard, but I think actually gamma's easier, the angle first. Does that make sense? Because you know two of the angles now,
Oh, well, that's,
and the third one is just the 180, they all sum to 180?
I meant capital C.
Oh yeah, you mean like the angle C, yep. So the angle which they're calling gamma is 180 minus 123 minus 24.2. So what do you get for your gamma? 32.8. Yep.
Wait, so what was that prime thing you showed?
That prime thing that I showed you comes from the fact that this equation has more than one possibility.
So what we need to show us for the test?
You will if you have a question where they both work. It's the only way to know is just to check. So I think that the thing to remember is that when you're applying your sine inverse function is you've got to find, sine inverse will only give you one of the values of what sine could have been, so you do have to just account for what the other one might be, and if it doesn't work, just rule it out. We will have an example where you actually have to use that, so I think it'll make a little bit more sense then. Okay, so we know gamma now. What are we missing? It's only to find this side C, right? So let's use the fact that sine alpha over A is equal to sine gamma over C. You could have used beta and B, that would be the same thing, yeah.
Just to make that clear, why didn't you do the two different angles for gamma like you did?
Oh, because once you know that beta can't be two things, gamma can't be two things.
Okay.
Once you know that beta is only one thing, there's only one possibility for gamma. So we'll have sine of 123 degrees over 47 equals sine of 32.8 over C. Okay. So that C's in the bottom. Does that make sense? So what I'm gonna do is I'm going to multiply the C over. C times sine of 123 over 47 will equal sine of 32.8. And so what's C gonna equal? Times 47 over sine of 123. Okay, so just tell me what that is.
30.3, that's 30.4.
Okay, 30.4. And this, the units of the sides, they said they were in centimeters.
So how did this?
You sure? So from here to here, I multiplied by C to get the C out of the denominator. Does that make sense? Is that the part that you were tricky?
Yeah.
Okay. Do you understand how this thing came over there and reciprocated? You understand why that is the way it is? Because to move this to this side, I have to divide by it, which is the same as multiplying by the reciprocal of it. Yep. Okay. They're a little bit tedious because there's a lot of things to find, but so really for this stuff, I mostly care that if I give you this in a test, it's going to be a word problem because I think that it makes more sense to do those problems. The important thing for this is you just do the Alex for this. Just get this over with and, you know, play with it a little bit and try. But I'll do a word problem if I do a word on the test. Try to set up the next one and see what happens. Like draw the picture, use the law of sines and see what you get. Yeah.
When it says like no triangle, are we not supposed to draw a triangle?
Nope, just do the problem and see what happens, and the fact that it says no triangle makes sense. Just try. Did you get, oh, you probably already did.
Wait, what is no triangle?
Okay, so we know that the A is 64 and the alpha is, I'm not answering yet, okay, just, I'm not trying to be, there's a reason. Okay, here's the angle beta. We know the B opposite is 79. We don't know that upper angle gamma, and we don't know C. So let's start the same way and try to find beta. So we have sine of alpha over A equals sine of beta over B. So that's sine of 57 over 64 equals sine of beta over 79. And so sine of beta is 79 times sine of 57 over 64. And so what do you get for sine beta?
1.0352.
And what happens when you try to inverse sine that?
Domain.
You get a domain error. So this thing has no solution. And what that means is that there is no triangle with this combination of angles side, as in it's just not possible. That side isn't long enough. Yeah.
So sometimes these can be like really long with a lot of steps. Could it be possible where like you're on like the last step, you're about to finish it, and then that's the one that's no solution? Or would you
I
find
think it will be pretty, I think that if it's no solution, one way that can happen is it's really obvious in the first angle you try to find. The other way it's obvious, which your textbook has an example of and it might come up, is if when you do sine of beta, you get an angle that's, when you do inverse sine, you get an angle that's too big. So I think that the both examples that I've seen, the ones that I am aware of, it's obvious at step one that you've gone wrong, okay? So now another possibility, just, this is possible, if you had gotten beta equal to like, I don't know, 170. So if you'd done a problem like this and your beta did work out and you got that it was 170, why would that be an issue?
You can't make a triangle out of that.
So the 170 and the 57 already add up to more than 180. So a good thing to check is when you find your first angle, check if alpha plus beta is less than 180, or whatever they are. And although it would be pretty obvious in your next step, because when you tried to find the third angle by doing 180 minus the other two, you're gonna get a negative number, right? So I think that I think that is probably gonna be pretty obvious in your first step. Okay. And so there was the first case we had where we ruled out that beta prime doesn't work, and this one there's actually two triangles that fit this requirement. So we'll find them and we'll draw a picture of them so that they makes a little sense. So you have a triangle with A is 1 meter, B is 1.8 meters, and the alpha is 26. So you have this little acute angle alpha. And my triangle is totally not drawn to scale, but this is 1. This is 1.8. Don't know that beta, C, and there's the gamma.
So
Mhm.
do you have to use alpha, gamma, and?
No, but your textbook did, so I'm worried that Alex will, so.
Okay, but if we remember.
If you wanna use A, B, like lowercase a, b, and c, and capital A, B, and C, I don't care.
Okay.
Okay.
Alex does use the capital.
And why doesn't your textbook do that? I don't know why, it's stupid. Okay, I'm sorry. Anywho. All right, so we know A and we know alpha. So sine of alpha over A will equal sine of beta over B. It also isn't bad to know some Greek letters because they're definitely going to come up. Just to know what, it's not bad to know what some Greek letter names are because they definitely happen. Okay, so we have sine of 26 degrees over 1 equals sine of beta over 1.8. So sine of beta is 1.8 times sine of 26. So when I did that, I got 0.789. Did you guys get that? So then beta will equal sine inverse of that. And what did you get for that? I got 52.1. Okay. So one possibility is the angle that's 52.1 degrees. What is the other angle there, which they called beta prime? 180 minus 52.1, which is, And then check, if you take this first one plus the alpha you know, is it still less than 180? Yeah. if you take this second one plus the alpha you know, is it still less than 180? Yeah, so both of these work. Both are possibilities. And what this corresponds to in a picture is that you have one case where that angle is obtuse, like this. That's the case where it's 127. The other one, that's the what they call beta prime, is if it is like this, and that's the angle beta. And you don't know which of the two it is. To see how both of those triangles still have the same little angle right there, right? It's just that one has an obtuse angle and one has an acute angle. And you don't know which of it is. That's why it says that there are two triangles. Your textbook and other textbooks call this the ambiguous case. There are two triangles that meet this requirement. So since you're just asked to solve it, you're asked to find both. If it was a physical situation and you knew that that beta prime had to be one or the other, you'd go with whichever one it was. So we'll do two problems. So if we just solve for beta, so we know beta is 52.1, then what's gamma gonna be? 180 minus 26 minus 52.1. Say that again, 101.9? Okay. So beta is 52.1, gamma is 101.9. In that case, what's the only thing we have left to find? C. So we have sine of alpha over A equals sine of gamma over C. So that's sine of alpha was 26, yep, over 1 equals sine of 101.9 over C. Multiply the C over and you get C times the sine of 26 equals sine of 101.9. And so C is sine of 101.9 over sine of 26. So when I found C was 2.23. Did anybody else get that? Or 2.2, if you, depending on how you want to round. Okay. And I'm not actually done yet.
The part that says both,
Yes.
so the other one, the number is like 170, so you knew that there's like not another angle, so how do we know that this one is smaller?
Because the other angle you're given, the alpha, is 26. And so when you take alpha plus both of these two numbers, you're less than 180.
Okay.
That's how you can tell that they would both work. Whereas in the previous one, like example 2, one of them didn't work because that angle plus the other angle we're given was more than 180.
Oh, okay, okay.
Okay, does that make sense? And so since we have this both, and we've still got to find the other case. So the other case is beta prime is 127.9. So in this case, there will be two answers, like as in two sets of numbers. The gamma will be 180 minus 127.9 minus the 26, so I think it's awfully close to 26. I got 26.1. And then let's do the same thing. Sine of 26 degrees over 1 will equal sine of 26.1 degrees over C. And you get C is sine of 26.1 over sine of 26, which I think effectively is just 1. But my point is that the stage at which you check to see if you have two possibilities is this stage. You check and see if when you find those two angles, do those two angles plus whatever you were given add up to less than 180? And that's, you know, if there are two possibilities or not. Yeah.
Do you have to do that for every problem that just says solve a triangle?
Yes, but in some cases it'll work out like example 2, where you can tell right away that it didn't work. Does that make sense? So if it says to solve the triangle and you have two possibilities that work, you do have to find both possibilities. Is that what you were asking? Yes, you do.
So,
Yeah.
if this pops up on the test, do you think we should just like have set 1 and set 2, and then,
Mm-hmm.
alright, and then, because I feel like,
It's gonna pop up, here's a hint. It's gonna pop up on Alex.
yeah,
It's not gonna pop up on your test.
okay.
It's too specific, and you don't use it often enough for me to justify it. I want you to have seen this thing so that if it comes up in an applied problem, you can do it again. But something this specific will not happen on your test. Something that might happen on your test is like the one that we did on the previous page that was about the elevators. That, I think that's more reasonable. And it takes too dang long, I'm testing a gazillion things on your final to
Yeah.
test all this. It's just too much. You have to do it in Alex, that's the only thing I'm gonna require from you. No test, no quiz. The test question will be like something easier. Now the other formula you do not have to memorize, okay? This is the law of cosines. And you prove this using something pretty similar to the previous thing. You use Pythagorean theorem, you draw a triangle, you bisect it. It's almost the same. I don't think I've got time to do it today. But this lets you handle the case if you have all the side lengths but don't know any of the angles. So, and notice that if that's the A, then everything else on this side involves the B and the C plus that angle. Does that make sense? So, and this involves the B, all this stuff involves A and C and the angle across from the B. Okay, so what you have to do is recognize these and know that they exist and also just know how to use them if given them. So, for example, this one, we have a triangle that has alpha 77.5, B is 10.4, and C is 17.7. And so perhaps it would work to also solve this with the law of sines. This one might. I think the next one with only the sides it won't, because the law of sines you have to know an angle. So here's my little picture of the triangle. So alpha is 77.5. A. B is 10.4. We put that in the same place I've been putting it all day. So B equals 10.4 and C is 17.7. Call this beta and call this gamma. And actually, I think on this one, you actually can't use the law of sines on it. It's not going to work. And the reason that it won't work is because you would need to know both alpha and A, or both beta and B, and you don't know that. So do you see how you know they gave you C, they gave you B, and they gave you alpha, right? So in this case, they gave you A and B and C, find A. So you know A squared is equal to B squared plus C squared minus 2BC cosine of alpha. It's awfully close to the Pythagorean theorem, isn't it? Yeah, so there's a reason for that, but it's kind of like a generalized Pythagorean theorem.
So you picked BC because you had B.
Because I have B and C, exactly. You pick the one that you have all of the stuff for. Does that make sense?
So is this just the Pythagorean theorem, like factoring in the fact that it's not a right triangle?
Effectively, yes. Yep, and that's what the book explains that a little better than I've got time for. So it'll be 10.4 squared plus 17.7 squared minus 2 times 10.4 times 17.7 cosine alpha. Basically, if you make alpha the right angle, it becomes the Pythagorean theorem. Like as if that's what happens. So that tells me A squared is, I got 421.45. Not done yet. minus 368.16 times cosine of that, I'm sorry, I should have plugged in alpha, it was 77.5.
I did all that.
And when you, if you do it all at once, I had a dumb calculator at home, so I was working this out in stages. I got a squared is 341.7656.
Yep.
And then I rooted that, and I got A was approximately 18.5.
And do we have to worry about like negative signs with this just because it's?
Nope, because it's a physical situation in which you know it's a triangle and its sides are positive, you only use the positive one. As your triangle would never have negative sides. Yeah.
So once we figure that out, then we can, start doing it like more on the paper.
Exactly, yep, perfect, you got it. Now that you know this side, you have to find the two angles you don't know, but you can use the law of sines. So once you use the law of cosines to get that side that you need, then you revert back to the law of sines. So you say, well, sine of alpha over A is sine of beta over B. So that's sine of 77.5 over 18.5, which we just found, is sine of beta over 10.4. And so sine beta is 10.4 times all that stuff. So I got sine beta is, I skipped a step. 0.5488. And so beta is, I got 33.3. And then can you find your last angle? So it'll be 180 minus 77.5 minus 33.3.
69.2.
Mm-hmm. Okay. So in that case, we had to use this law of cosines just because we did not know a side and an angle combination that would have allowed us to use the law of sines. And the law of cosines, that formula definitely is the part that comes up in certain applied problems in calculus. You've got to use it to do something else. So it's good to have seen it so you know how the angles and the sides of the triangle relate to each other. But you're probably not going to actually be to solve a triangle explicitly in calculus. All right, this one is a little bit different. Why is it a bit different?
Just have the signs.
We just have the size. It's the first time we have been given a single angle. So A is the shortest side. Let's see if I can draw this. So you've got A is 1.25. You've got B is 1.52. And side C is 2.05.
I thought C was 1.52.
Oh, sorry, C is 1.52. Yep. So C is 1.52 and B is 2.05. So we're like, Okay. So I'm afraid your textbook did not explain this well, and I didn't have enough time to look it up. Find the largest angle first. All they do to explain is they say it eases confusion. And it was really an inadequate explanation. They didn't give anything else. So You have to find the largest angle first with these situations. So which angle will be the largest angle, alpha, beta, or gamma? Beta. So we want to find beta. And look at those formulas that you're given at the top of the page, and which one of them involves beta? The first, second, or third? Second. So you got b squared equals a squared plus c squared minus 2ac cosine of beta. Yeah.
Will your answer be wrong if you find?
I did it, and yes, mine definitely was. It somehow ends up being wrong, and I did not think through, I didn't have time to think through it and think about why it was wrong. So I'd have to go back and think about it more. And like I said, they just didn't give any explanation as to why that was necessary that I could find. It will be, but it definitely, I did it wrong the first time, and it did end up being incorrect. I think that what happens is you just get a sum of angles that they don't add up correctly to 180 somehow. Because if there's only one combination of sides, there's not gonna be two triangles that have that combination of sides. So,
I think I did that in Alex,
Mhm.
and I got two possibilities, and I kinda guessed with one of them.
and it could be, I mean, I have to work through a couple more problems to see why it ends up being wrong, but my suspicion is there aren't two possibilities that have these specific sides, but there are two possibilities, like there wasn't in the previous example. So you might be mixing up the two cases because they're so similar.
Yeah.
I didn't do beta first, but I got 180, is that a coincidence or?
That's a coincidence. And not doing beta first definitely doesn't work. Like I did it, it doesn't work. So I just think for now, this is not too much, it's not important to perseverate on it too much. So 2.05 squared, 1.25 squared minus plus 1.52 squared minus 2 times 1.25, 1.52 cosine beta. So after all this squaring and adding, I got 4.2025 equals 3.8729 minus 3.8 cosine of beta. So what would you do first to solve for cosine beta? Mm-hmm. And you get negative 0.0867. And then you divide by, oops, I'm so sorry, guys. I just don't have my brain on today. If you subtract, you get 0.3296. Then you divide, and this should be, you get negative 0.0867 equals cosine beta.
I got 0.0643.
Did I copy, I might have copied my calculation down incorrectly. Anybody else do it? Did you get this the same?
I didn't get anything, so not.
Hmm?
I didn't get anything, so not. Oh, yeah.
And what did you
I
get?
submitted.
What about this stage? What did you guys get for that number right here?
I got the same number.
Negative,
You got the same number as me?
negative 0.0867.
Okay, so I think if 3 or 4 of us got it, you probably made a mistake. I don't know what it was, but it happened. Okay, so beta is cosine inverse of that number. So beta, what do you find for that? I got 95. And actually, I know I checked this answer, so I'm 95% certain I'm right. So if you apply cosine inverse, you get 95?
I got
Yes.
85.
85?
You got 85. Did you do something differently?
Let's try beta.
What? Yeah.
I got 95, but I started with, I'm just not sure why it's happening because I started with C. I
Mhm.
found C first, but eventually I still got 95 for B. So I just don't know.
I think it works sometimes. When I did this, I started with A, and I got 85 as well, Rachel. So when I did this problem the first time, I also got 85.
Yeah,
But did you do it the exact same way as me and get 85?
Yeah, I started with A and I got 85, and then just the largest angle, and I started with B and I got 85 again.
You shouldn't have. Something else must have gone wrong, okay? It's a sort of, I'm happy to look at it, but there's some other kind of coincidence going on there. Okay, because I definitely know that we get 95 when you do it this way. Everybody else got 95 when they did cosine inverse of that number?
Yeah.
Yeah, okay. Tani, what's up?
So in between that, the last two steps, you're just plugging that number into the inverse cosine.
Yeah, I'm just doing cosine inverse of negative 0.0867. Yes. Yes, okay. Holy moly. Okay, now, we got one angle. Beta is 95. How about next? Any angle? Alpha? Yeah, so sine of beta over B will equal sine of alpha over A. Man, I hate these problems. So you have sine of 95 over 2.05 equals sine of alpha over 1.25. I am just going to tell you what I got because I want to actually do one of the word problems. This is the actual interesting thing. You get alpha equal to 37.4. And then you get gamma equal to 47.6.
What was gamma?
47.6. Basically, once you get this first angle, you have to revert back to using the law of sines, just like we did in the previous problems. So I think that what might happen is if you don't do the largest angle first, you might occasionally get lucky, but it's not going to consistently work. Don't ask me why, because I have not got a great explanation, okay? Like, it's just, I'm not going to come up with it in front of you. It's not, yeah, I get it. I get that it's, I also feel that it's unsatisfactory. I don't like it either.
Like, I got it right on Alex.
Like I said, you can get lucky sometimes, right? I mean, like, it happens. Okay, so let's do one of these applied problems. You have two kites. You want to know how far apart they are. And this could be something different. You could have two roads and they diverge at an angle you want to know. The kite thing is kind of stupid, but it could be the case that you've got two roads, want to know how far apart they are. So you want to know the length of this side. So give it your favorite letter. Well, maybe be A, B, or C. A. Do you see how then we can use the law of cosines to figure it out? You'd have A squared equals B squared plus C squared minus 2BC cosine of alpha. And you've got everything you need to know. So that will equal, doesn't matter who, 113 squared plus 97 squared minus 2 times 113 times 97 times cosine of 27. This is one of those cases where the word problems are better than the non-word problems. And I got A squared was equal to 2,645.35497. And so A is the square root of that. Did you guys also get the same number? Still subtracting, okay. You do know you can punch that all in one go, right?
I don't wanna,
You don't wanna?
no,
Why do you wanna make it more work for yourself?
because when I did these in high school, I had a stupid calculator, so I'm super used to doing it that way.
Fast, speed is key. Anybody else get this yet, or are you still punching? You got it? Okay. And then I got 51.4 feet for the distance. And that seems plausible, right? Because you have an acute angle, so this definitely should be less length than the other two sides. Okay. The next question is about Bill. Have you guys seen those goofy bee-like Bill things?
Oh,
Yeah. Yeah. So Bill wants to know the length of the tunnel, and he doesn't want to measure the tunnel. We're going to assume the tunnel is straight, as not curvy. So he makes, this is kind of how this applies to surveying, is you know the distance from where you are to a point, and the distance from where you are to another point, and you also know the angle in between. And so you can use that to find this distance. That's how it comes up in surveying. So once again, you can call this side here A, right? And you can say A squared is B squared plus C squared minus 2BC cosine of alpha. And I'll just tell you what I got for A squared. I got A squared to be 7,847.3708. And then I got A was 280.2.
When you do it on your calculator and you plug in that big, long thing,
Mhm.
do you multiply by cosine 80?
Yes, you do.
Okay.
Yep, you
I
do.
love how he makes the measurements underneath the mountain.
Well, it could be next to, right? I
Yeah.
mean, like, it's a 3D picture drawn in 1D.
Yeah.
And I want to do the last example. You got out 10 minutes early yesterday. We're going to hold you over like 2 minutes today because it's actually not going to be that bad. How do you find the area of a triangle in general? If you know the triangle. Area is 1/2 base times height. Okay. So does it make sense that I could make a perpendicular thing there and that's going to be my H? Okay. This triangle, you know that the base is 12. And so can you somehow use trig to get the H? Yeah. So you know that you have the opposites. So the H is the opposite. So we'll say sine of 33 degrees will equal H over 8. Does that make sense? And I chose to use sine because I need to somehow incorporate that opposite side that's H, right? And then I need to use the hypotenuse, which is 8. And so that tells you that your height H is 8 times sine of 33 degrees. And the area is 12, 1/2 times 12 times 8 sine of 33 degrees. And that didn't really involve any use of the law of sines or cosines. It's kind of how you prove the law of sines, like you show it using that information.
Why did you use sine?
I used sine because I needed to know the height of my triangle. And relative to this angle right here, that is the opposite side.
Oh,
Does that make sense?
yeah.
And so I think I need to use a trig ratio that involves the opposite somehow. And that's either sine or it's tangent, right? But tangent's out because then I would also need this adjacent side, and I don't know that side.
Okay.
Does that make sense? So hence the use of the sine. Does that make sense? Okay. And so when you calculator this, you get, well, 48 times sine of 33 degrees, or 26.1, and what are its units going to be?
Meter squared.
Meter squared.